Yes. Which problem? Yep. All right, guys, before we get started, we're going to look at problem number 35. Yes. So this is a problem from 3.52. All right, guys, so we're looking at the homework assignment from 352. Now, one of the first things we need to do to solve this by completing the square is really to get our like terms together. So the first thing I would do here is, first off, I would subtract the 10x from both sides, telling us that we have 4x squared minus 40x is equal to 12. Now, the next thing we can do is we can subtract the 12 from both sides to get it equal to 0. However, there's not a whole lot of reason to subtract the 12, because if we were, so completing the square, first one is a equal to 1, if not make it so. Second step is to get the constant term by itself, yes? Is the constant term already by itself? Yeah, so I mean, we could subtract the 12 over, get it equal to 0. We would divide and then immediately move it back over. So there's not a whole lot of reason for us to take this 12, move it to the other side, and then move it right back. So since the constant term is already by itself, we don't have to do anything with that there. All right, guys. Now, is a equal to 1? No. So what we have to do is divide all three terms by 4. 4x squared divided by 4 is x squared. Negative 40x divided by 4 is negative 10x. Plus blank is equal to 12 divided by 4 is 3. This here. I went on and added the blanks because, again, the constant term is by itself, so we can move straight into step 3. Step 3 is find the value of c. C is equal to b over 2 squared. Our value of b in this case is negative 10. Well, negative 10 divided by 2 is negative 5. And negative 5 squared is 25. So at this point here, we're going to add 25 to both sides. Now we're going to factor and solve. So when we factor our x squared minus 10x plus 25, we would have x inside the parentheses, and then we'd have the number inside the parentheses before we square it, which is negative 5. And 3 plus 25 is 28. Now at this point here, we're going to take square root of both sides. On the left-hand side, the square root and square would cancel, telling us that x minus 5 is equal to plus or minus. At this point here, we need to take square root of 28, which is 2 square roots of 7. And last but not least, we need to add 5 to both sides, telling us x is equal to 5 plus or minus 2 square root of 7. Did I kind of answer that question there for you? Yeah. Yeah. Because we needed to get the x's together. That was the key thing. Now, the constant term already being by itself, we can move it with the other two terms. We can leave it by itself. Either one works. We just need to pick one or the other. Questions on any other problems? Good so far? All right. I believe this here is the problem we left off on. Yes, 5x squared equals x plus 8. Yeah, we did just the first page. All right. Looking at this here, to use the quadratic formula, we need to get this equation equal to 0. What can we do to get this equation equal to 0? We can indeed subtract 5x squared from both sides. So we get 0 is equal to negative 5x squared plus x plus 8. Ax squared plus bx plus c is what we're relating this back to. So a, our number in front of x squared would be what? Negative 5, yes. Because we need the number and the sign. Number in front of x, 1, our b value is 1, and c is 8. And we do want to take the sign in front of it. Now a and b will do, neither one of those will have a variable. A will not contain x squared and b will not contain x. But a is going to be negative 5, b is 1, c is 8. Our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So at this point here, we need to plug in the values of a, b, and c. So we'll have negative. Our value of b is 1. Plus or minus the square root of 1 squared minus 4 times our a value, which is negative 5, times c, which is 8, all over 2 times a, 2 times negative 5. Now, negative 1 is going to simplify to, well, negative 1. In the bottom, 2 times negative 5 would be negative 10. And our next thing to simplify is our 1 squared minus 4 times negative 5 times 8. So in the calculator, we can do 1 inside parentheses squared minus 4 times negative 5 times 8, which is 161. Questions on how we got to this point here? Well, the next thing we'll need to do is see if the square root of 161 simplifies. It does not. Now, there is one last thing we need to do. We need to get that negative out of the bottom of the fraction. Now, all that means is that we're going to take this negative out of the bottom and distribute it back through the top. So, the denominator is still going to be 10. However, our negative 1 is going to become 1. So it's going to turn the negative 1 to positive 1. Now we also have this sign in the middle. So the plus in the plus or minus is going to become minus. Well, the minus is going to become plus. Because a negative times a negative makes a positive, and the positive times a negative makes a negative. So the positive became a negative, the negative became a positive, giving us back the plus or minus. That's kind of the nice thing with the plus or minus. When we multiply by a negative, it just stays plus or minus. There are some things in mathematics that work nice like that. There. Questions on this so far? We good with this one here? Now, the main issue that we came into this was the fact that a was negative. That's why we had that negative in the bottom of the fraction, yes? So, you don't have to change what you have on your paper. I'm going to show you something here. So we can erase that. Because what I could have done up here is divided everything by -1. Well, 0 divided by -1 is 0. Well, the negative 5x squared becomes positive. The positive x becomes negative. The 8 becomes negative. Let's do this green here. Well, so 5 is now, our a value is now positive, b is negative, c is negative, yes? Let's see how that changes it. Well, that's going to be negative, negative, positive, negative, positive. Well, that means our -1 is now 1. Our 2 times 5 is now 10. Well, that matches up closer to our final answer, doesn't it? Now let's see how that changed what's inside the radical. Because now we have -1 squared minus 4 times 5 times -8 is still 161. Nothing simplifies, so we're done. So it does make it a little bit nicer if the value of a is positive, not negative. We don't have to worry about that negative in the end. But that's about it. Does that make sense? We're ready for the next one. 25x squared minus 8x equals 12x minus 4. Again, we need to get this equation equal to 0. What can we do first? We can subtract 12x. Telling us that we have 25x squared. Negative 8x minus 12x is negative 20x is equal to negative 4. Well, that kind of tells us what the next step is going to be. We have to add 4. Telling us that we have 25x squared minus 20x plus 4 is equal to 0. What's the value of a? 25. Value of b? Negative 20, and c is 4. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we need to plug in our values of a, b, and c. So our first one is negative b. Well, that'd be negative 20. Plus or minus, well, again, b squared, so negative 20 squared. Minus 4 times a, well, a is 25. C is 4 over 2a, 2 times 25. Luckily, now our negative 20 is going to be positive 20. 2 times 25 is 50. Now we need to plug in everything inside the radical into the calculator. Well, we could do it by hand, but I have a feeling y'all are going to plug it into the calculator anyways. In this case, we're going to get 0. Oh, Now the question is, can we take the square root of 0? Yeah. Because squares are what? We're trying to find out what times itself is the number inside the square root, our radical, yes? So what times itself is 0? 0. Scroll down just a little bit. So we're saying that x is equal to 20 plus or minus 0 over 50. Well, we can add and subtract this, but it's not going to, because we can say that we have 20 plus 0 over 50. Well, what is 20 plus 0? 20 over 50. 20 over 50 reduces to what? 2/5. All right. Technically, we also have 20 minus 0. Well, 20 minus 0 is 20 over 50, so x is what? 2/5. We just need one. Because realistically, we do have two answers, but they're both the same answer. So for this here, we only have one unique solution. We have two solutions, we just really have one unique solution. Because again, the textbook is going to say that we have one solution, one real solution, which we do. And then the next chapter is going to say that we do have to count it twice. Contradiction, but yeah, we do have two real solutions. We just only have one unique solution for this here. Questions on this here? We ready for the last one that we're going to use the quadratic formula on today in class? Because we're going to do one more of these. Negative x squared plus 4x equals 13. We want to solve it using the quadratic formula. So we need to get this thing equal to 0. So how can we do that? Minus 13 from both sides. Tell us that negative x squared plus 4x minus 13 is equal to 0, yes? Now we can leave it like this here and solve, because we already did one like this earlier, yes? But the thing that kind of made it a little, we had to change in the end was the negative, yes? Because a is negative. So it might make it a little bit easier if we went on and just made it, what? Positive. Because we can just divide everything by -1. We can multiply everything by -1. Really all we're doing is just taking the signs and switching them all the way through. Still gives us the same solutions, it just makes the numbers work better, work nicer. Because now a is +1 instead of -1. Our value of b is -4 instead of +4, and c is +13 instead of -13. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to -4 plus or minus the square root of -4 squared minus 4 times our a value of 1 times 13 all over 2 times 1. So it gets that negative out of the bottom of the fraction. We don't have to worry about fixing that negative later. Now at this point here we have -4, which is just 4. On the bottom of the fraction, 2 times 4 is 2. Well, there's a good chance we might have to simplify because 4 and the bottom 2 do have a common factor of 2. So if that radical, when we simplify it, has a common factor of 2 with it, we're going to have to simplify it as well. Now let's plug everything inside that radical. Negative 4 squared minus 4 times 1 times 13 is negative 36. Now it would be very tempting to want to go second square root negative 36, but it's going to give us a domain error. Because again, the 30xs cannot take the square root of a negative number. But we can. Because when we look at this here, we know that the negative is going to come out as what? I. Since we took the I out, that negative does come out as I. What we have left is a square root of 36, which is 6. Which means the square root of negative 36 is 6i. Huh? We still got to simplify. Because everything has a common factor of. So we can divide everything by 2. So 4 divided by 2 is 2. 6i divided by 2 is, and the 2 on bottom simplifies out completely, telling us that our solution is 2 plus or minus 3i. Yep, the first 4 are this year. We ready for the next one? Analyzing the discriminant. Now, the discriminant specifically is this b squared minus 4ac. You do not have to write all this down. Also, I don't think there's enough space on your paper to write all this down. The main key thing, let's get a highlighter, not a crayon, is this part here. Because the discriminant is going to have one of 3 things. It's either going to be greater than 0, equal to 0, or less than 0. B squared minus 4ac can be greater than 0. And if it is, we have 2 real solutions. Or it could be that b squared minus 4ac is equal to 0, which means we have one real unique solution, but for us we can just say one real solution. And we also have that b squared minus 4ac is less than 0, so we have 2, I call it complex solutions, or we could say imaginary solutions. I have a feeling it's just someone working on the roof. Either that or it's just really windy. Questions on this so far? Are you ready to see how this works? Find the discriminant of the quadratic equation. Describe the number and type of solutions of this equation. Okay. Yeah. Now the first one here, we still need to find the values of a, b, c. Well, A is 1, B is -6, and C is 10. So the first thing we need to do is find the value of b squared minus 4ac. Well, b is -6, or a is 1, c is 10. So the first part of this problem is just finding this value. -6 squared minus 4 times 1 times... Ah, thank you. I've been wondering why it gave me a domain error. Is -4. So the discriminant here is what? Less than 0, yes? So that means we have 2 complex solutions. That's it. Yeah. Be ready for the next one. Well, x squared minus 6x plus 9. Well, a is 1, b is -6, c is 9. So now we have -6 squared minus 4 times 1 times 9. Is 0. So the value of the discriminant here is 0, which means we have what? 1 real Yes, sir. Questions on this here? We're ready for the next one. Well, a is still 1, b is -6, and c is 8. So we'd have -6 squared minus 4 times 1 times 8. Anybody have a guess at what this value is going to be? 4? Yeah. If we've got -4, 0, 4. -6 squared minus 4 times 1 times 8. So we have 2 real questions on this here, how to find the discriminant, number and type of solutions. Do we feel good with this here? Do we need to see another type, one of these? Do we feel good? Yeah. Okay. The only thing I would say is, if, especially like these here, we do need to get it equal to 0 so we know A, B, C. But that's it. So your homework is 6 through 16 even, and then 21 through 24 all. Tomorrow is makeup day. So that means we have finished with this here. We're going to test next week, because tomorrow will be a makeup day. Friday will be the review. We'll go over it Monday, and then we're going to test. There is one other part of 3 that we're going to do, but it's going to be after. It's going to be nonlinear systems. Well, I don't include it in the chapter test. It's pretty much solving a system. Where does the line and the quadratic cross? Possibly. Well, that's right. So it wouldn't be, yeah. So Monday is professional development.